Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Geographic, and I'll be your host for today. October is behind us, so we've put an end to our space exploration events for now. I'm sure we'll mix in a few more as the school year goes on. We've got some really cool themes this month, including for the first time, archaeology, paleontology, and geology. So if you want to check out some of those lessons, you can head to exploringbytheseat.com and find those there. A newsletter went out as well yesterday, so check your inboxes. We also have a really cool event going on this week, which we're kind of carrying over from last year as well. CNN has their Call to Earth Day this week, and we're teaming up with them to do a full Call to Earth week. So hosting some really cool scientists, explorers, conservationists, adventurers from around the world who are doing their part to drive awareness and education around key sustainability issues and to inspire positive action. So Call to Earth is a CNN editorial series, and they're committed to reporting on environmental challenges facing our planet, as well as some of those solutions. So their Call to Earth Day is officially on November 6th, but like I said, we like to go big here, and so we have a whole week of live events for classrooms. So visit the website, you can find all of those there. We had our 2 events this morning that saw us in the UK, then bouncing down to South Africa, and now we're going to spend a little time in Canada. So we have Alison Criscitiello joining us, an ice core scientist and high-altitude mountaineer who explores the history of sea ice in polar and high-alpine regions using ice core chemistry. This involves long months of living in a tent and drilling ice cores in places like Antarctica, Alaska, and the Canadian High Arctic. Alison is an assistant professor and the director of the Canadian Ice Core Lab at the University of Alberta. She's also the founder and co-director of Girls on Ice. So I'm going to reach backstage, see if we can get Alison in here with us. Hey, Alison, how you doing?
I'm doing great. Hello from Banff.
All right, good stuff. Well, Alison, it's great to have you with us. We've got classrooms from Canada and the US tuning in. So a shout out to them, and don't be shy to use the chat sidebar and send us in some questions for when the time comes. But Alison, we want to get into your world on the ice for a little bit before we do that.
All right. I'm going to share with you a PowerPoint because I would love to talk while you don't look at my face, but you look at some pictures. Okay.
Perfect.
Let's do share.
All right. I see it loading backstage, so that's a good start.
Okay. Can you see the first page here?
I think you just have to bring it up to the front for us, Alison. We still see the StreamYard screen. So so I'm here too. There we go. Yeah, if you go down to the bottom, there should be a menu should pop up with if you just go all the way to the bottom with your mouse.
Stop.
Because we're already sharing screen, so we're good to go.
All right.
Cool. Yeah, but the PowerPoint, I think, is just tucked behind the other screen, so we just have to bring it to the front.
I've got it on the front on mine.
Okay, we'll figure it out. Sometimes technology, we just had a really good test in the green room, so I'm sure we'll get it going. I'm not too worried about it.
Let's try again.
All right, so I do see the screen share. Let's see if we can get the presentation up to the front. It may be, Alison, if you try moving, like if you grab onto this screen and just move it over, and maybe then we can kind of click the presentation to the front.
Yeah, you can't see it right now?
No, that's so strange.
Okay, let's do stop share. Share screen.
Yeah, I'm sorry that it's acting up right now. We just had a really good test. But technology will always kind of do this to us, I think. There it is.
Okay.
Perfect. We're good.
Oh, sorry. Thank you for bearing with me. Okay, well, I'm so stoked. Thank you for inviting me to talk to you today. I just want to give an overview of what it is that I do, ice core science. Why do I do it? How do I do it? And I'll use one project as an example to kind of tell you this story. Now, Joe, can you hear this?
Nope.
No? Okay, I'm going to skip the initial video then. And I'm So the work that I am going to share with you to kind of tell you this story all takes place in the St. Elias, which is a big mountain region in Canada. And just wanted to start off by saying that this is First Nations territory, and I'm privileged to be able to work on it. It's the territory of the Kluane, the Champagne-Ajac, and the White River First Nations. So first of all, why would we drill ice cores? Well, ice cores, they preserve chemistry over time. So as snow falls and it gets buried and buried and compacted and more snow falls and it buries and buries, it's preserving that snow over time. So you can kind of think of depth down as a time scale. And this means that if we're able to somehow drill down and extract that, then we can look back in time and we can learn things about our past climate. Now, so what kind of things can we look at in our past climate? Well, we look at a lot of different things in ice cores, things that we almost always look at in, most of the ice cores we drill. We reconstruct temperature over time. We do that by looking at oxygen isotopes, and those give us an idea of what temperature was doing over time. There are different things we can look in the ice core, black carbon, and these things called polycyclic aromatic compounds, PACs, and these are indicators of wildfires. So we can look back at in time and see, hey, was wildfire frequency changing over time? Are wildfires becoming more common in recent decades? So that's something we commonly look at, especially these days in non-polar ice cores, when we really care about what future wildfire activity might be. And then another kind of more recent thing we've used ice cores for is looking at anthropogenic pollution, meaning pollution caused by humans. So we can actually measure all sorts of different environmental contaminants, things that we use in our daily lives that get put into the environment and are transported through the atmosphere and actually make their way to the most remote parts of the planet. And then we can measure them in ice cores. And they can tell us a lot about the transport of these chemicals over long distances to the remote parts of our planet. And then one other thing I just wanted to highlight, because it's sort of my original area of expertise, is we can learn all things about the ocean from ice cores that are from land. So I wrote marine productivity here. So we can actually look at things that phytoplankton, the little tiny critters in the ocean. We can look at changes in sort of how happy they were and how productive they were, which is related to sea ice cover, because they have something in their cell structure that gets released into the water column and exchanges in the atmosphere and actually precipitates in snow. So in this kind of convoluted way, we can learn about sea ice in the past, how much sea ice there was in certain parts of the world's oceans in the past, by looking at these chemical markers in ice cores. But again, to come back to kind of generally why we do this, the ice cores allow us to look back far, far back in time, way before we have observational records where humans are actually observing the planet, whether it's here on the ground through all sorts of different ground-based methods or whether it's through satellites. So ice cores are one of our most powerful tools for looking very far back in time to understand Earth's climate. So I said I was going to give you an example of kind of how we do this and why it's important. The example I was going to give you is Mount Logan. Now this is a non-polar ice core, which is kind of special. A lot of the cores that we drill are in the high Arctic, Greenland, the Canadian high Arctic, or they're in Antarctica. But there's some really special spots on the planet that are high enough and cold enough that they retain these long climate records over long periods of time. So Mount Logan's one of them, and me and my team drilled an ice core on the summit plateau of Mount Logan in 2022. Now, why is this a good place for a record? Well, we care a lot about this because there's actually a lot of people around this area. You can see where that arrow is pointing. It's kind of in this little corner near where Alaska comes together with the Yukon and also BC. And there's lots of communities around there. And so I mentioned at the beginning with the land acknowledgement, the St. Elias is the region I'm talking about. The St. Elias, that red arrow is pointing toward a mass of white. That whole mass of white is the St. Elias ice fields, and it's actually the largest non-polar ice field in the world. So you can imagine it's probably climatically important for climate in the Pacific Northwest, where a lot of human population lives. Mount Logan is also the second tallest peak in all of North America, Denali being the highest, just over the Alaska border there. It's almost exactly the same. But Mount Logan in mass is much bigger. Here's a picture of 18,500 feet on Logan. That's a spot called Prospector's Call, which is important because we installed a weather station on there, which I'll show you in a minute. But here's just some views of the St. Elias from parts of Mount Logan. Now, so why would we go to this probably pretty hard to get to place to drill an ice core? Well, I said at first, of course, some of the longest records we have are from the polar regions, and that's because they've been cold for really long periods of time. They don't melt, and melt destroys the climate record. So we're looking for these kinds of places. It's unique to find them outside of the polar regions. This is a high altitude site. It's almost 20,000 feet, or 5,959 meters is the summit height in meters of Mount Logan. So of course it's very challenging to navigate altitude and extreme cold in all of these conditions. But the reason I would say it's worth drilling these non-polar locations is because they contain information about non-polar regions that may be particularly important to cities, people, communities, ecosystems that are closer to them. So in this case, we may be able, with this core, to evaluate long-term climate variability in the Pacific Northwest, something that we maybe couldn't do even with an Arctic core that's from just north of it over the Arctic Circle. So I mentioned there's this weather station in a particularly inhospitable spot on Mount Logan. It's not one of my favorite spots. I've climbed Logan 3 times, once for fun, quote unquote, and skied from the summit to the base. And then I went back this year with my climbing partner who's in the yellow jacket there, Rebecca, and we installed a weather station, which is at this high col at 18,500 feet. And this was a really important year that we did before we went out to drill the ice core. And this is very common. We'll go out before we drill, so a whole year before we drill, often to install weather stations to start getting really detailed information on weather. And we also, I'll show you in a moment, usually do a comprehensive radar survey to pick our core site. So again, this is a full year before we're going to be drilling. So we installed this weather station. You can see all these sensors. There's that little black thing on the top. That's the wind vane. We look at relative humidity, solar radiation, and it starts to give us a little bit of a look. There's the top left. There's the weather station again at a different angle. At weather in this really high spot on the planet. And we lack meteorological observations from the highest parts of our planet for very obvious reasons. They're hard to get to, and they're also hard to instrument. They're really hard to maintain these stations. You usually want to visit them once a year, fix broken parts. Going back every single year to a spot like this is probably too difficult to do. So this is a really special station. And if anyone's interested, I think you can Google it and it comes up, but it transmits real-time weather data every 5 minutes to a public website that anyone can view. So you can see just how nasty it is at this spot. But a bunch of scientists have already utilized the weather data from this station, which is really exciting. On the top right, you're looking at the summit ridge of Mount Logan with the St. Elias in the background, looking kind of toward the interior. And then the bottom two are just bits of the route. And I think probably show, that's Rebecca and I in the two, and they kind of illustrate perhaps maybe why the kind of ice core science I do is a little bit unique. This high altitude ice coring that requires you both to be an ice core scientist, but also to have a solid background in high altitude mountaineering and be able to safely do this kind of work. And so this is kind of why I really love this sort of work the most. Here's the top two images here are showing you the radar. So I mentioned we have to go out this whole year prior and pull these funny systems and sleds around. And the reason for doing that is we have to figure out some way to pick the best site to drill our ice core. And the way we do that is by essentially imaging from our skis all the way down to the bedrock below. And these radar systems, they send out a pulse of energy, and that pulse of energy will reflect off all the internal layers in the snow all the way down to the bedrock. And we get these reflections both from those internal layers and from that final reflector at that bedrock ice interface. So this will tell us how deep the ice is at various spots. It will also show us kind of the stratigraphy, meaning the layering in the ice, so we can find somewhere that isn't disturbed. If there's funny ice flow and there's kind of waves in the ice, and you can imagine sometimes you see this with rocks, with old metamorphic rocks that are folded and twisted. That happens with ice as well. Ice is flowing. And we have to be able to date the ice. We have to put that depth onto an age scale to be able to do anything with it. So we have to look for areas where that layering is just flat from the surface all the way down to the bed, so that we know we can date it. There's nothing funny happening with overturned ice or things like this. So that's what this the slide in those top two photos is showing you. And it's a pretty simple system. There's a transmitter that's being pulled right behind the skier, and then there's a receiver in a sled that's towed behind. And here's another picture. It looks like we're just pulling it around to move it, but that is a larger radar system that's actually on in that picture. So there's a bunch of different ways to configure it, but this is what the ground penetrating radar looks like. And you ski around in a grid, and then you gather all of your radar data to analyze. And here's just a quick snippet again of coming up to that spot at 18,500 feet, just to give you an idea of what it really looks like. There's the station with the St. Elias spreading out below. And we did return. You can see, did you notice there at the top that black wind vane is missing? That black wind vane lasted 1 year. And so we did replace it the next year with an acoustic wind sensor, which is a wind sensor that has no moving parts. This is Rebecca and I during the drilling year. So now I'm bringing you to 2022 as we're leading up back to the Logan Summit Plateau. Now we've identified the core site, and we're climbing Logan. Again, took about 9 days to get up to our drill site. Now here is my extremely uncomfortable drill site on Mount Logan. So a lot of people ask, what is it like to actually do this work? What does the camp look like? How do you survive and live? And I'm probably a terrible person to ask. I'm pretty minimalist, I think. This core is long. Was over 1,000 feet long, over 300 meters long. So it took about 2 weeks to drill. And this is what the camp looked like. So this is an aerial view looking down. On the top, you can see those 4 dots. And those are just sleeping tents. They're not heated. They're just normal mountaineering tents. So everyone gets their own sleeping tent, sometimes 2 to a tent. And then on the bottom, you can see three larger domes. So one of those, the drill is in it. And we do that. It's a floorless drill tent, you'll see in a minute, so that we can drill when the winds are really high, when there's big storms, and we don't lose drilling days to bad weather, because there's a lot of bad weather. And then those other 2 big ones there are both sort of living tents. One is for kitchen, so that we can all cook together and have a little bit of warmth there. And then the other one is just gear, because you actually can't leave things out on the surface because it's so windy and stormy at sites like this. Stuff sort of gets buried overnight. It's remarkable. So you kind of have to have everything contained. So that other one that's kind of yellow orangey, that's just holding drilling and living equipment. And then if you see, everyone asks this, so I'll preempt it. In the middle, there's one kind of reddish tent. You can see it's kind of snow drifted. That is our bathroom tent, which is just an ice fishing tent. It's a floorless little pop-up tent, well tethered down with a painter's bucket in it. So this is your most minimalist, but sort of my more typical style of kind of fast and light camp. Okay, so here's inside the drill tent that I just showed you. So this was drilling in 2022 on the Summit Plateau. Now this drill, you can see on the mast where's the Canadian flag on it. It says Eclipse Ice Drill. This is a really cool drill built here in Canada, kind of designed after a Danish tipping tower drill. And we call this a tipping tower drill because you can see that whole boom and the big drill sonde, they're vertical right now, which means I'm drilling. But when it comes up to the surface, I think you'll see in a second, the entire drill, the whole thing, except for that control box that I've got my hands on, the whole drill swings to a horizontal position. So it's tipping tower. The entire drill swings on a pivot. And that allows us to drill. We drill a meter at a time. And then when we pull that meter of ice we've drilled up to the surface, we swing the whole thing up and we pull that meter out and repeat. over and over and over. And here's the outside of that drill tent. So we did have to fly fuel up there in this case, which you always do. We have a small generator that powers the drill, but it is extremely fuel efficient, which is wonderful for a number of reasons. And on the right there is probably the crudest ice core processing field line you'll ever see. And this again was because of kind of altitude constraints. But when the ice comes out of the drill, here's a meter of ice sitting there that Rebecca's holding on to. All she's going to do is measure it, weigh it, and then package it in a bunch and kind of baby it in packaging to get ready to fly off of the summit plateau. On the left, obviously that's looking down kind of from the top of the drill, and you'll see there's that steep sort of trench. We call that an incline trench because it kind of scoops down, and that's because it's a tipping tower drill, right? So we have to be able to swing that drill all the way up to the surface. So we've got a trench there, and other than that, right, we just have a snow floor, and that's kind of the space that we're working in. And here's the drill, and yes, it is as monotonous as my big sigh there would indicate, but it's really fun, and the nature of drilling changes over a season because when you start, you're really near the surface, so you're just bringing core up to the surface really fast. You could drill about 30 meters in a day in the first couple of days. There's our ice core boxes ready to fly there, each full of 9 meters of core. But as you get deeper and deeper over time, the drill has to travel all the way down that borehole just to drill its 1 meter and come all the way back up. You may only drill 1 or 2 meters a day when you're hundreds of meters down. So the nature of the season kind of changes, and as you're deeper later in your drilling season, it may offer time for people to do more surface snow science and add some other science components. So it's always kind of changing. And then, so here's just the drill in action for a second, some snippets. That's the inner barrel of the drill that we pull out every time we've drilled a meter. Here's the drill swinging up to the surface. Here it is being lowered down and then coming back up from that borehole. And it's a pretty seamless drill. After we finished the drilling in this particular project, folks were asking as well, okay, well, once the ice was all off, then what? Well, then what? We got to ski down, which is a very wonderful ski. It's about 10,000 feet. We skied down, but that's only after all of the ice, all of the equipment, every single thing, of course. We either packed into our sleds and skied down, or we flew off of the summit plateau with a helicopter, leaving absolutely nothing behind in this very beautiful and sacred place. And just as a last kind of comment, because I think when you see, photos and images of places like this, or you think about high mountain regions, or you think about the poles, they seem untouched, right? They seem like pristine and kind of like maybe the last places on Earth that would be impacted by changes in our climate and warming. And this actually isn't true, especially when we think about the high mountain regions of the world. There's a process called elevation dependent warming, and all that funny word or combo of words is describing is the process by which some of the highest elevation parts of our planet are actually warming at a faster rate than lower elevations. And so this is one thing that we're looking to explore with this new Mount Logan record. So some of these highest places on Earth are actually the ones that are most impacted by climate change. And just a quick note, because I really love Q&As and I want time to talk to you all, is just that, I'm sitting here presenting to you today, but this kind of work requires an enormous amount of support, often a lot of different countries, and a lot of different people to pull off. And so in this particular case, there are lots of different funders of this work, several nations. We work with the local First Nations too, and just a lot of collaborators. So I'm speaking on behalf of a huge team to do this kind of work. Okay, so I will stop sharing.
All right. Alison, thank you so much. What a cool presentation. What a cool workspace. I have a picture here that I have here tucked backstage. This was from a while ago, but this was an event you did with us one time. Let me see if I can bring it in here.
Oh, is it the Columbia Ice Field?
It 100% is. Yeah.
Nice.
So I was going through some of our stuff and I came across this photo where you were out in the field doing a live event for us with classrooms out in the ice field. It's pretty cool.
I love that you pulled that up. That was one of the first times I did this, and I loved it so much. That's why I'm doing this today, and I still do these classrooms. And that spot is incredibly important. I'm standing on Snow Dome, which is kind of the high domed part of the Columbia ice field,
Yeah.
which is the source of my own drinking water. It's a water tower. And we were drilling that year there. You see that red barrel with the orange spiral on it. That's a shallow core, right? A shallow drilling system. So not nearly as intense as the one I just showed you. And we drilled 20-meter cores that year we were actually looking at contaminants, environmental contaminants up on Snow Dome.
Very cool. Well, next time you're in the field, you have to let us know. We're using much smaller, lighter units now, and it's way easier and costs like a tenth of what it used to. Less. It's, yeah.
Amazing.
Pretty cool. Yeah. All right. Well, let's get into some Q&A action. I've got questions coming in via the chat, which is great. So we're going to have lots of questions here. And the first question I have here is from a classroom in Toronto. There's some fifth graders, and they're wondering, you take the ice core off of the mountain, then what? Where is it now? What's happening to it now?
Okay. Well, every project is different. This is a great question. In this case, okay, right. So we have like an actual ton of ice sitting in this terrible spot. Then what? Yeah. In this case, because of the high altitude, and because it was such a long course, 327 meters long, it's over 1,000 feet, right? Obviously, we can't put that in sleds and ski it down. And also it's high enough that helicopters can't safely land because they won't be able to actually lift back off. So I should have showed you a video of this because it's a really good question, but we actually had to sling all of the ice off in small 300-pound loads. The payload for a helicopter at that altitude is quite low.
Yeah.
So it's only 3 to 4 ice core boxes at a time. And so sling load, what does that mean? Well, it means I'm standing there, me and my team are standing there on the surface, and a helicopter on a really good weather day comes and hovers over us and drops a 200-foot line with a net on the end, and it just stays there and hovers. We load our ice core boxes into the net, clip it on, go like this, and then it just, without landing, just hovering the whole time, it takes off, and then it goes and brings it, in this case, to a freezer that we stationed at a location that it was safe to land at much lower elevation.
Yeah.
And we basically, you do that load by load until the freezer is full. And then that freezer, like it stays around -30. It gets trucked across the country. So it was in the Yukon, and that freezer truck went from the Yukon all the way to Edmonton to the Canadian Ice Core Lab where my home base is. So that core now is sitting there, but we have cut it up, we've imaged it, we've done an enormous amount of the analyses, and so that was drilled in 2022, and the first paper is it's been submitted. And that sounds like, wow, it's like the end of 2025. That's a really long time, but it's actually pretty fast. So like the timeline of different kinds of science is different, but but that's the journey that ICE took in this case. But every project is different, and the truth is those logistics that you're asking about take years to plan, to make sure the ice, safely makes it back to Edmonton, where the Canadian Ice Core Lab is.
Yeah. And so they followed up with, obviously in this situation, things went really well, but as there ever been times you or maybe colleagues have lost their ice cores because just something went wrong?
Yeah, I mean, I have to say, I think everyone in the business has had it happen. Sometimes, I mean, even, it's much like just spending time in the mountains, right? There's just some things that you can't control. I actually haven't personally, I don't think I've personally had that happen to myself, but whether it's ice that's somewhere in its transit and something happens, or one of these big national repositories like the Canadian Ice Core Lab, which before I arrived did have a melt event. Sometimes something catastrophic does happen at one of these places that's holding the ice, in the spot that it was its final place to get to, and then something happens. So it definitely does happen.
All right. I've got a class in Winnipeg that want to know, you mentioned bad weather days. So what do you do if you can't be out on the ice doing what you need to do? What do you do for the day?
Yeah, it can be really boring. You get kind of homesick. But the truth is, with those floorless dome tents, it has to be very unsafe, like really high winds, high enough that you have no visibility tent to tent, where you're making a call to just have everyone stay in their tent. Only conditions like that will we not work in, because that big floorless dome tent lets us work in pretty bad weather. But that's kind of the call. The call you're making is, can you travel from tent to tent? Do you have the visibility, and can you stand in the winds, right? If you can't really see where you're going, even if we string lines from tent to tent, which we do, it's not safe. And for that reason, we have sort of a emergency food, toileting, and way to make water and heat in every single tent in case you can't travel from tent to tent. But then even in a place like this has notoriously horrific weather, there were only a couple days total of the whole trip like that where you just have to stay put. That being said, like 3 days out of 30 still feels like a lot. But we are able, as long as you can see and like the safety call is there, we can continue drilling in pretty bad weather.
Okay. Okay. Fourth graders in North Bay, Ontario. Does the drill ever get stuck?
Does it ever? These are great questions. Yes. So the shallow drills, like the one actually that Joe showed you in that Columbia icefield photo, get stuck a lot. This drill, this Eclipse tipping tower drill, it doesn't as often, but when it does, we have a really cool technique for getting it out, and it's pretty effective, so you don't really lose your drill, but what you do is you ruin your borehole and you have to start over again. This has only happened to me once so far. It's happened to me several times with that shallow drill, but it's only happened once with the Eclipse drill in West Antarctica. And when it's stuck, there's, mechanically, there's not really anything you can do. So what we do is we make what we call ethanol bombs. But you basically make like a water balloon, but you fill it with ethanol, which has a very, very low freezing point, right? So if you just took ethanol and out in the winter and poured it on the snow, it would start to melt. You would just watch it melt the snow. So we make a little water balloon of that, and we chuck it down the hole, and it breaks on top of the drill. And we often have to do that a few times. And then you just give it some time. You give it a couple hours before you try to pull. But it melts it out. It turns it into total slush. But what you're doing, right, is making that borehole all of a sudden have a cavern. So right. It's ruined. But it releases your drill. And this, it kind of happens to all of us here and there. But it's happened to me once so far.
Okay.
Yeah.
That's what I was going to ask does that mean that site, that hole is toast, or you just ignore a section of it because it was?
No, the hole is toast because when you've created, you have that nice straight borehole, but then you've created a cavern,
right.
You can't send the drill back through it because it won't follow a straight trajectory. It will get stuck again.
Yeah.
Yeah. So
okay.
It's done. Yeah.
Okay. I've got some students in Ohio that want to know, out of all the careers you could have chosen, what attracted you to a cold career where you're kind of out in the cold and the ice and working like that?
Well, thanks for the cool question. I think I came to ice core science because I loved winter sports, and I love the season of winter, and I love mountaineering. I did all those things, ice climbing and skiing since I was really little, and just really, really loved exploring in the cold before I got interested in the science I do. So it does look kind of miserable, and it is in some ways, but It's actually like loving being in those places. A lot of that through sport, really.
Yeah.
That made me come to the science that I do. And
Okay.
that
Oh,
was
sorry,
from
go ahead.
Ohio. That was from Ohio.
Yeah.
Okay, Ohio has the Bird Polar Research Institute, which is one of the most prolific sort of ice core science and glaciology centers in the world.
All right. Very cool. Maybe they can get a school trip or something going.
Hmm.
Yeah, very cool. Okay, so next question. This is back to an initial class who was joining us from Toronto. And they're curious about anything surprising that you found in a sample or from the information you've collected.
Yes. I have to say, to me, the most surprising thing that I've found in ice cores that we've drilled are these environmental contaminants. It's something I didn't look at before the position that I'm currently in. I was mentioning at the very beginning that marine sea ice kind of work, and that's what I did for a long time. Once I started doing environmental contaminant reconstructions, I've been pretty shocked. And I should say these are analyses that we're looking at things that have been looked at in other parts of the environment, but had never been analyzed in ice cores before. In part because it just seemed like they'd be in such low concentrations we couldn't really find them.
Yeah.
So when we started drilling ice cores to see, hey, can we actually measure certain kinds of contaminants and are they even measurable? And then, if they are, which, wow, they are, that was surprising in and of itself. Can we actually, are there trends in them that make sense in terms of, production of certain chemicals and all these kinds of things? And as we kind of unraveled that story in some cores that we drilled across the Canadian high Arctic, I would say, in terms of surprise factor for me, that takes the cake.
Okay. I've got a few more questions coming in the chat. Curious about the drilling process and wondering if you ever have trouble with the drill because it has any trouble with maybe friction on the ice. And then they're wondering about the ethanol that you use to release it. Doesn't it vaporize really fast? How come it's able to melt? Yeah.
Okay, the first one. Yes, there are, aside from just getting stuck, there are all sorts of other mechanical failures that can happen with a drill like that, the Eclipse drill I showed you. I think some of the worst ones have happened to me, one on Logan, which is that there's a motor section on the drill, which is the thing that has those, I don't know if you saw it, but those 3 arms, which are what hold it in the borehole and keep it from spinning.
Yeah.
They're called anti-torques. But inside those anti-torques is the motor. And basically, anything in there can break. And there's a transmission. It's a motor. The transmission, because of the altitude and one of the seals breaking, it went on Logan. And the drill engineer calls it the heart of the drill. I would say that is the most catastrophic thing that could happen. He fixed it in the field. And I also always bring a second motor, an entire second motor, even though it's super heavy. But, you try to bring replicate, or basically a full drill replicate if you can, because these are such hard and expensive projects, but, you're also weight limited. Yeah. All sorts of things can break, even the cutters, things like that. But we do bring a lot of spares. So we're just fixing things as you go. The thing like the motor, that the drill was down for a day to fix that, with the drill engineer who was with me working the entire day to fix it. So that does happen. Yeah. Ethanol does vaporize quickly. But basically you just need it to serve its function for a few hours. And remember what we did with it, we dropped it down a borehole where there's no circulation, and there's some circulation happening, but very little. When it splashes down on the motor, it's completely surrounded by impermeable ice. There's no you're below bubble close off, meaning the air that's trapped in the ice at that kind of depth, anywhere that that drill's getting stuck would happen.
Yeah.
It's not connected, right? So it's essentially in a little impermeable box. It's open at the top of the borehole, but it just has to be effective for a couple hours as it's melting, which is, yeah, like, yes, it does vaporize quickly, but it's able to do its thing. Like it doesn't vaporize that fast.
Perfect. I've got some third graders who want to know what the food is like. What's food like in the field?
It's disgusting. That's not true of polar work, I have to say, where you're not weight limited. I mean, you are in some ways, but not that weight limited, and you can fly fresh food and all sorts of stuff. I was in the Arctic for 2 months this year drilling, and we had incredible food. This kind of high altitude work, it's disgusting because it's all dehydrated. You have to carry it there. You need to bring at least a month, usually more, of food. It's an enormous amount of food. And it has to be as lightweight as possible, which means it's all dehydrated or freeze dried. So you're just reconstituting, like boiling dried food.
Yeah. I could see how that could get tiresome over a span of time. Final question for you, Alison. What is next? Do you have an expedition planned? And there's a kind of a second part to it. What would be a dream destination if there is one?
Oh, top secret questions. But
Okay.
I'll share with you. You showed Snow Dome, which just made me smile for a number of reasons.
Yeah.
And I said we drilled shallow cores. I think there's a lot of folks in the community, including myself, interested in finally drilling a full surface to bedrock core on the Columbia ice field.
Yep.
And so I think that's something you'll see us do in the next couple of years for sure.
Very cool.
And was a dream?
It's like a place maybe hard to access or you've been dying to get to.
I have my eye on a spot in the Karakoram, which is in the Himalayas. And this would be the next kind of Logan-like, but a bit more extreme, I suppose. Like really out there, remote, very high altitude target. Yeah.
Yeah. Very, very cool. And I want to start off. Thank you so much for joining us on our first day of our Call to Earth action and taking us the last two events that start us. We're in the ocean, so taking us up to some altitude and out into the ice. That's great. I want to give a shout out to our classrooms. Thanks for tuning in. A shout out to those who will tune in to this week if you couldn't make it live. And as always, Alison, it's so great to steal some of your time. Yeah, really appreciate it. And the next time you're out on the ice, we should talk about getting that into the classrooms.
100%. And thank you so much for having me and for the awesome questions.
All right. We're going to sign off for now. We've got one more event today and then a whole bunch more coming up this week. So exploringbytheseat.com, and we hope to see your students with us as the week goes on. For now, thanks, everyone. Right. We are